To all my little Algebra 2 people that had to miss school this week, I hope you're okay. I made this little video here to catch you up with what we did in class. So we've been graphing quadratic equations. You should have watched my other video on vertex form. This first thing, just a review of that. Y equals a parentheses x minus h squared plus k. Alright, this one's the easy one to graph. Do y'all remember which part of the equation tells you the vertex? It's the h and the k numbers. Remember, the k right here shifts the graph up and down. The h moves it left and right. So your vertex, if it's in vertex form, is just whatever number h and k, whatever those are. Alright, now this video is focusing on what's called standard form. Problems like example 1 right here, y equals ax squared plus bx plus c. That's the standard form. Y equals ax squared plus bx plus c. Now this one's a little harder to graph. You can't just look at the problem and know what the vertex is. There is a formula to find that vertex. That vertex formula is x equals negative b over 2a. Right? That's my formula to find the vertex. Now axis of symmetry, that's just like a line of symmetry you learned about back when you were in junior high or middle school. When you have a parabola like that, remember a line of symmetry or an axis of symmetry just cuts it into a mirror image, kind of like that. That's an axis of symmetry. Now, what's special about that is that axis of symmetry, it cuts through, what's this special point right here? It's the vertex. So, the formula for axis of symmetry is the same as the formula for the vertex. X equals negative b over 2a. If you know one, you know the other. Now, one last piece of information I need to throw at you. The y-intercept in the standard form, the y-intercept is always that c number, the number at the end. Y-intercept is just the c. That's where your graph touches the y-axis. So that's the only part of the graph I can tell just looking at the standard form. I can find the y-intercept. So if you look at example 1, I have y equals x squared plus 2x minus 3. First of all, which number is the y-intercept? It's the negative 3. That's my y-intercept. So I'm going to start by graphing that. I know it's going to touch the y-axis here at negative 3. Now I need to finish this graph. I know it's going to be a parabola because it's got x squared in it. It's going to look like this. What's the most important point on that parabola? It's the vertex. I need to find the vertex. And there's a formula to find the vertex. What's that formula? X equals negative b over 2a. So I need to use that. X equals negative b over 2a. And in the problem, here's a, here's b, here's c. Now if they don't put a number in front of x squared, what's that mean? It means that's a 1. Alright, so I'm going to plug these in negative b, so x equals negative 2 over 2a. 2 times the a number is 1. I need to work out the bottom and then divide it. So 2 times 1 is 2. Negative 2 divided by 2, going to be negative 1. That's the x number on my vertex. So I know the vertex is going to be negative 1 comma something, and the axis of symmetry is x equals negative 1. So here's where people tend to make their first mistake. A lot of people, they do x equals negative 1, they get that from the vertex formula, and then they try to put negative 1 right here at the top. The vertex is in the middle of the graph. So where do you think it makes sense to put this vertex number? In the middle of my table. I'm going to put negative 1 right here in the middle. And I need to pick numbers on both sides of negative 1. So numbers like negative 2, negative 3, 0, and positive 1. Those are my x numbers. Now I need to find the y numbers. Anytime you know x numbers and you need to find y numbers, I can do what to find the y numbers? I could plug in the x numbers into the original problem. So I'm just going to go back to my original problem, plug these in. Now you're thinking, wait, I got to plug in all 5 of these? No, not necessarily. Let's start with the easy ones. All right, I'm going to start with 1. That'll be easy to plug in. So if I plug in 1 for all these x's, y equals going to be 1 squared plus 2 times 1 minus 3. And then PEMDAS. Please excuse my Darren Tally. I got to follow order of operations. Parentheses, then exponent, then multiply and divide, then add and subtract. So 1 squared, that's 1. 2 times 1, that's plus 2. And minus 3. What is 1 plus 2 minus 3? It is 0. So when I plugged in 1, I got 0. So I know that I have the point 1, 0 in this table. So I'm going to plot that point on the graph. 1, 0, going to be right here, right on the x-axis. What's another easy x number to plug in? How about 0? Let's plug in 0 for all the x's. So that's going to say y equals 0 squared plus 2 times 0 minus 3. Now that one's easy to work out. Can you tell what the answer is? It's going to be negative 3. 0 plus 0 minus 3 is going to be negative 3. So I plugged in 0, I got negative 3 out for y. So I know I have the point 0, negative 3. And we already plotted that point. That's the y-intercept. So let's do one more. Let's plug in the negative 1 in for all these x's. And I need to put it in parentheses. So y equals, parentheses, negative 1 squared plus 2 times negative 1 minus 3. Now, order of operations, be careful with the negatives. Negative 1 squared, that's negative 1 times negative 1. So that could be negative 1 or positive 1. It's going to be positive 1. Positive 1, 2 times negative 1 is going to be negative 2 minus 3. 1 minus 2 minus 3. So 1 minus 2, negative 1 minus 3, negative 4. So I've got the point negative 1, negative 4. And that is my vertex. I can go ahead and fill that in down here. Negative 1, negative 4. And I'll plot it. Left 1, down 4. Right there. Now you might be thinking, okay, this is already a lot of work. Now I still have to plug in these negative 2, negative 3. No, not necessarily. Because, remember that axis of symmetry, it cuts the shape into mirror image. I know what this half of the graph looks like, so I already know what the other half of the graph is going to look like. This is going to loop around, come back up. And so these y numbers are going to be mirror images of these y numbers. If this one's negative 3, that means this one's got to be negative 3. So I'll have the point negative 2, negative 3 right there. And if this is 0, I know this number has to be 0. So it's going to be negative 3, 0. So there is my parabola. Now, if that last thing just confused you, yes, you could plug in negative 2 and negative 3 and for x, work it out, you will get those numbers. But it's much quicker if you could just remember the pattern. Okay, so now I want you to flip over to the next page. I want you to pause the video and try to do examples 2 and 3. Did you do that? I hope you did. Let me show you what the answers are. Example 2, first of all, the y-intercept is 4, so your graph should touch at the 4. I need to do x equals negative b over 2a. Now be careful, b is a negative 4 this time. So I'm going to say x equals negative b, so positive 4 over 2 times 1, you get x equals 2. You put that where? In the middle of the table. And then pick numbers on both sides of 2, plug them in for x. So like we plug in 0, 1, 2, 3, and 4. If I plug in 0, 0 squared minus 4 times 0 plus 4 gives me 4. If I plug in 1, I get 0. Plug in 2, you get 0. And then these numbers are going to be mirror images of that. So you should get 0, 4, 1, 1, 2, 0, 3, 1, 4, 4. There's that parabola. And the vertex, of course, is 2, 0. Axis of symmetry, x equals 2. Example 3, this one's a little tricky. All right, you may have some mistakes on your y numbers when you try this one. First of all, y-intercept, positive 3. Should be touching right here at the 3. X equals negative b over 2a for the vertex. So negative b, so positive 2 over 2 times negative 1. So 2 divided by negative 2, which is negative 1. I need negative 1 in the middle of my table. Pick numbers on both sides. Plug them in. Now be careful when you're plugging in the x numbers this time because of this negative. For example, if I'm plugging in, well, if I'm just doing positive 1 right here, if I'm plugging in 1, that negative needs to be outside the parentheses. I would have negative parentheses 1 squared minus 2 times 1 plus 3. So order of operations, you're not doing negative 1 squared. You are doing exponents, then multiplying. 1 squared, which is 1, then times the negative, going to be negative 1 minus 2 plus 3, which gives me 0. All right, same thing like, for example, when I plug in negative 1. I have negative parentheses negative 1 squared minus 2 times negative 1 plus 3. So order of operations, got to do parentheses, then exponent, then multiply by the negative. Negative 1 squared, negative times negative is a positive 1, and then put that negative on it. Going to be negative 1. Negative 2 times negative 1 is plus 2, plus 3, going to give me positive 4. So my y number should be 0, 3, 4, 3, 0. Looks like that. All right, now there is one more page to this note. We're going to get that in a different video. So hopefully you understood that. You feel free to email me with any questions.